Moving on to section 4.2, we're going to be dealing with rational exponents. Now, rational exponents are exponents that have ratios in them, namely fractions. So I kind of want to teach you a little bit about what a fraction exponent works like. And I just realized that there's a typo on this page. There we go. So it shouldn't say 8 to the 1/3, it should say 27 to the 1/3. Sorry about that. Okay, so when you want to figure these out, I'm going to give you a little hint, which is that you've actually seen these before, just generally not in this form. So let me remind you about a property here. If you have 16 to the 1/2, we don't know what that is yet, but just bear with me. If you had it and you raised it to the second power, what will happen? That's 16 to the... Now what can you do with those powers? Well, by the the rule of exponents, you can multiply them. But what is a half times 2? That's equal to 16 to the 1, which is just 16. You with me? Well, that's interesting. So that means that 16 to the half, here, is a number that if we square it, we get 16. That suggests that, oh, hold on a second. And let me make this smaller so I can try to fit this all in there. There we go. That suggests that 16 to the half is actually equal to, okay, now think about this. What number can you raise to the 2 power, can you square and get 16? 4, right? Because if you take 4 and you raise it to the 2 power, you're going to get 16. There we go. All right, and let's maybe remind you. Okay, so I'm just trying to help you guys see what 16 to the half must be. 16 to the half is 4, because if you square it, you'll get 16. By the same token, 27 to the 1/3, okay, that's 27 to the 1/3 times 3. But that's 27 to the 1, because 1/3 times 3 is 1, which is 27. Right? I think everything there. Okay. Now, what number can you raise to the 3rd power and get 27? So you can think to yourself, okay, I need something that I would raise to the 3rd power. 1 to the 3rd. Not going to work. 2 to the 3rd. Not going to work. That's 8. 3 to the 3rd, right? And honestly, I expect you to know these just from your times tables, but still. 3 to the 3rd is 27. That's it. Because it's the number that when you raise it to that power, you're going to get 27. So that has to be 3. And now you've learned a very important lesson. Do these look familiar? So what does that mean? 16 to the half is equal to, oopsie, I'm sorry, is equal to 4. We just said that. But that's because it's the square root of 16. Right? Square root, because there's a little 2. When you do a square root, what you're really doing is a 2. We don't write them like that because we're, you guessed it, lazy, yes, but that's the case, right? So when you do 16 to the half, you're really doing the square root of 16. And that also means that, excuse me, the 27 thing, let me do it right here, 27 to the 1/3 is equal to the cube root of 27. The number times itself 3 times, that gets you 27, which doesn't have another notation because we're not that lazy. And we write 3. Okay. I should put these together. Hold on one second. So that's what we just learned. And that's what's in the blue box, right? The definition box. So when you take, okay, and again, these work slightly different if they're odd or even. So when you take an odd root, b to the 1 over n is the number whose nth power is b. We call it the nth root of b. So if you heard what I said, I was like, oh, that's the third root of 27, right? 3 is your n, right? So you'd say 1/3 root, or the third root, okay? And then if n is even, like 2 over here, if n is even and b is greater than 0, which it was for us, it's 16, right? So if that's the case, then that's called the principal nth root of b. So 4 is called the principal square root of 16, okay? Because 4 times 4 makes 16, if n is even. And b is less than 0, then it is not a real number. Doesn't mean it doesn't exist. It means that it's not in the number system that was labeled the real numbers by René Descartes in the 1600s or whatever. Okay, so we represent b to the 1 over n as the nth root of b, like that. See that notation on there? That's what I was doing up here. So this part right here, I wanted you to notice that, right? Because that's critical. There we go. I just made them bold to make it more obvious. All right, so let's practice. So when you see 49 to the half, you could write that as, let me write it down here, 49 to the 1/2 is equal to, now according to that bottom part, I could rewrite that as 49 square root. But we all know the square root of 49, which by the way you could also write without the little 2, is 7. Right? Remember your times tables? Hold on. Actually, yeah. Because 7 times 7 is 49 in your times tables, that's why the square root of 49 is 7. Now you could also do it with your calculator. Let me show you. Like if you forget. I mean, generally you're doing the ones that are down here. These are so simple. But if you're doing harder ones that you don't know off the top of your head, this is how you do it. So you go 49, raise it to the 1 divided by 2, like that. Now, if you're in this little notation, then you can do this because it's got the half all up there in the power, so I can do that. Old notation, you have to do 49 caret parentheses 1 divided by 2. If it doesn't put it up in a little superscript like mine is right there, then you're going to have to use parentheses, right? Because you have to get 7. So grab your calculator right now and check and see whether you need parentheses or not. If you don't have this little upper notation for exponent, then you're going to have to use parentheses. Or you could do a decimal, 49 caret 0.5, if you know the decimals. But that'll only work for decimals that'll work out nice and even. Right? Okay, so we did that. Now 27 to the 1/3. Well, that's interesting because it's the same one we just did above, but that's okay. I'll just write it again. 27 to the 1/3 is equal to the third root of 27. Oh, I guess I don't need to do it that way. 27 to the 1/3 is equal to the third root of 27, which is 3. Awesome. All right, what about negative 27 to the 1/3? That's not too bad. So you just need the number. So you're taking negative 27, you're taking the third root of it. Okay? And that would be negative 3. Right? Because what you're doing is you're trying to figure out what number times itself 3 times would make you 27, negative 27. Now, the other way to do it, you have calculators. So let me bring it up. Hold on one sec. There we go. So we can do this a couple ways. Parentheses, negative 27, close parentheses, to the 1/3. Now, I don't have to use parentheses on that exponent because I've got this new operating system. But if you're in the old operating system, you can do 1/3 in parentheses up there too, and press enter. And see, it's negative 3. Now, there's another way to do it. Let me show you. If you press 3, I haven't done this with the new operating system yet. Oh, there it is. Hold on. Quit. Third roots are actually in the computer, so let me press clear. All right, so I press math, and you see number 4 right there? It's saying it's going to take the third root of whatever you want, and then you just type negative 27. Enter. There you go. That's another way to do it. Okay, so you could take parentheses, negative 27, close parentheses, to the parentheses 1/3. And again, I don't actually have to use parentheses on the exponent because I'm on this new system. All right. So now what about 32 to the 1/5? So you've got to think to yourself, okay, what number could I raise times itself 5 times and get 32? Well, it should be pretty obvious to you, but if it isn't, that's one of the ones that they make you know a lot in textbooks, because it's really easy. So you want 32 to the 1/5. That means you want the 5th root of 32, which means, if you don't know it, I know it, it's 2, but if you don't know it, let's try it. You could go 32, it's all positive, so you don't care about parentheses on this one, caret, and then parentheses if you need to, 1/5. Right? I don't need to, so I'm just going to do 1/5 because I've got that superscript notation there. Okay. So it should be 2. Now there's another way to do it. If you press 5, then go to math and pick number 5. See number 5? Number 4 was third roots, only third roots though. Number 5 is any root you want. So if you pick number 5, it automatically for me is making it a 5th root. But if it just says X root symbol, that's fine. 32, enter. So that's another way you can do it. There's 2 ways you can do that with your calculator. So using the root features in the math menu, or using the parentheses with the exponent. Either one's fine. The problem with the root method is that you have to translate it to the root perfectly. If you just leave it 32 to the 1/5, you can just do it like that without having to fiddle around with, wait, what root was that? And where was the square root thing under the math menu? So you can do it with just 32 caret 1/5, or you can do the 5th root of 32 by pressing 5 and then going to math. Oh, and just real quickly, just so you notice, above your x squared is the plain square root. Regular square root with a 2 in front of it, that's right there above your x squared button. All right, so let's do the next one. Negative 81 to the 1/4. So remember, that's really negative 1 times 81 to the 1/4. The only part that has the 4th power is actually the 81, because there's no parentheses, right? Right. So this is really negative 1 times, now 81 to the 4th is what you need to figure. So you could do, it's really the 4th root, 4th root of 81, if you want to think of it that way. So that's negative 1, if you will, times 3. 4th root of 81 is 3, if you don't believe me. 81 to the 1/4. And again, you would need parentheses around the 1/4 if you're doing old school. So it'd be 3. Okay, so there we go, which means it's negative 3, just like I said it was. All right, last one. You want to make it just like what you just had, but you'd be in trouble if you did. This is negative 81 to the 1/4, which means, let me type that, hold on. There we go. Means the negative is in there, underneath that square root sign, underneath that. It's called a radical sign is what it's called. We'll learn more about them in chapter 9. But it's not like C. C had the negative out in front with no parentheses, or E, sorry. But F has it inside. That's more difficult for you, because that means that this has no real solution. Right? Because there is no number that you can raise to the 4th power and get a negative like that. And if you don't believe me, try it on your calculator. Negative 81 to the 1/4, again, parentheses around the 1/4 if you're old school, non-real answer. It is not a real answer. You can't take something to an even number of powers and get negative 81.